Alright, so the video we're doing today is going to be on rhombi. So rhombi are a lot like parallelograms, but they're actually a little bit easier. So what we have here is it says rhombi have the same properties as parallelograms. So that means that opposite sides are congruent. So we'll go through and we'll do that. Opposite sides are congruent. And then it says opposite sides are parallel. So we'll do that. Parallel marking. Same thing here. Alright, it says opposite angles are congruent. We'll do that. Alright, it says consecutive angles are supplementary. Now again, we have no markings for that. And diagonals bisect each other. So, draw in your diagonal. Oh, let me see if I can fix that. Okay, close enough. And then what we have is that they bisect each other. So, 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. Great. So they've now been bisected. Now, what we have is a couple of things that make life just a little bit easier in most instances. So, something we have here, one of the most important properties of rhombi is that all sides are congruent. Alright, so all sides are congruent, meaning that these should all have 2 marks because they're all exactly the same size. All 2. Perfect. Now, what we also have is that opposite angles, so opposite angles, or actually let's go through we won't write that. What we'll write instead is that diagonals bisect opposite angles. So what that means is that right here, let's go through and give this name, A, B, C, and D. What we have is that angle B has been cut directly in half. Okay, so we have angle B is made up of 2 parts, and they're both exactly the same size. So in parallelograms, they're not the same size, but in these ones, they are exactly the same size. So B has been cut directly in half. Remember, bisect means in half. So we'll give just one example of that. Let's look at angle B. So angle B has been cut directly in half. So let's go through and we'll put a little E here. Not that we necessarily need it, but we'll call it the measure of angle A, B, E. So A, B, E, that's this one right here, is exactly the same size as C, B, E, the measure of C, B, E. So these 2 parts are exactly the same size. And every corner works that way. So angle A has been cut directly in half, angle D has been cut directly in half, and angle C has been cut directly in half as well. Now, another thing that we need to know is that the diagonals are perpendicular. And I'll give you the symbol for that as well. Perpendicular. That symbol is the upside down T. What that means is that we have right angles in the middle. Alright? And I'll do those in orange so we can see them a little better. So you have a right angle right here. You have a right angle right here, and right here. Which means we have 4 itty-bitty triangles, and they're all right. So we have right triangles. So for example, triangle ABE is a right triangle. All right. Now let's move on to some of the examples. So what we're going to do is use those facts that we were just talking about. So it says that JK is 12. So let's do 12 for JK. And let's use that first fact from up there. It says all sides are congruent. That means that we have 12 here, 12 here, and 12 here. All right? It then tells us that JN is 7, which means that NL is also 7. Those are both 7. So we can fill in the things that we know. So it says JM is 12. We've already marked it. JL is 7 and 7, which gets us 14. MN, we don't know MN. How could you find MN? Well, yes, it's a right triangle because we have that they, in number 3, right here, it says they're perpendicular. So, if you need to see it, you can go through and draw it. It looks like this. All right? And we have 7, we have 12, and then we have X. How would you find that? Yes, we should use the Pythagorean theorem. So remember, hypotenuse goes alone, so it's 12 squared equals X squared plus 7 squared. I'm going to pause the video and I'd like for you to solve this. Alright, so what we should get here is that MN is the square root of 95. Now what do we do if we have MN is the square root of 95, but they want MK? So they want MN and MK, or the total of MK. So one thing we should know is that they match each other. So this part right here is the square root of 95. This one right here is also the square root of 95. So how many square roots of 95 do you have? Perfect, we have 2. So it's 2 square root 95. Because you have 2 of them going from M all the way to K. All right. Now let's go through, I'm going to pause, let's go through and mark everything we know in the second example. All right, so all I've done is go through and it says RT is 22, so I divided it up into 2 parts of 11 each because they match. And then US has been divided up into 2 parts, so 9 and 9 for a total of 18. So let's see what things they ask us for, because maybe we don't have to do the Pythagorean theorem. So VT, we've marked as being 11. UV, we've marked as being 9. RS, oh, we have to find RS. So we're going to put our right angle here. Remember, in the middle are all of our right angles. And then we're going to look for RS. Oops, that's supposed to be an X. But we're looking for our hypotenuse. So what we'll do is we'll do the Pythagorean theorem up here. So the thing we're looking for is our hypotenuse, so it goes alone. X squared equals 11 squared plus 9 squared. All right? So I'm going to pause and see if you can do this alone. So what we get here is that we have the square root of 202, because 202 only breaks down into 2 and 101, and 101 is actually a prime number, so no pairs. So our final answer for RS will be the square root of 202. That is our side length. Now they ask us for ST, and one thing that we know is that all of our sides are exactly the same. So since we already found the square root of 202, this one is the same, the square root of 202. All right, and we're going to leave that in radical form. We will not be changing that into decimals. All right. Now for example number 3, it asks us about a bunch of angles. So a bunch of angles that we should be able to find. So the one thing that you have to remember here is that every corner has been bisected, meaning it is exactly the same size on either side. So for example right here, this angle right here that I just put in purple has been bisected or cut directly in half. So if this bottom section is 38, then the top section is also 38. So for angle 3, we have 38. All right, and directly opposite is exactly the same thing. So we have 38 degrees and 38 degrees, and that's for 4 and 5. And something that we should know going on in the middle, if we go back up, it tells us that the diagonals are perpendicular, meaning that in the middle are all right angles. Right angle here, right angle here, here, here. Now they only asked us about angle 8, or like the number 8 angle, and that one is 90 degrees. But it will help us to find all the other ones. So what I'm going to do is I'm going to highlight one of the triangles. There we go. So in this triangle, we have a 90-degree angle, we have 38 degrees, and we have missing angle. So what we do for that is we need to find what gets us to 180, because every triangle adds to 180. So we can call this x, and we'll do x plus 38 plus 90 equals 180. You can do this mentally as well. Some people go through and say 180 minus 90 minus 38, and that gets you the same answer. So we have x plus 128 equals 180, and that's going to get us x equals 52. So that means angle 2 is 52. So I'll erase that. And we'll put a 52 there. And because it's been bisected, angle 1 is also 52. And since the corners are the same when they're opposite, these are both also 52. All right. All right, great. Now, we're going to go through, and it looks like for number 4, we should be able to do absolutely everything. We're going to find all of the sides. We're going to find all of the angles. So I'm going to pause as you go through and do this. I'll just show you the worst answer, so go ahead and pause. All right. So I've gone through and solved everything, and I'll just go through and give you a brief overview. So for WZ, we got 34 because all of the outer edges are 34. Because in a rhombus, all of the sides are congruent. For VY, I just went through and I split 38 in half because the diagonals bisect each other. And then for ZV, I had to go through and do the Pythagorean theorem again because I have a right triangle. Alright. And 34 is our hypotenuse here because it's directly across from our right angle. So we have 34 squared equals 19 squared plus x squared. And that got us the square root of 795, which does not simplify. As I show you, we get 5, 3, and 53. And those are no pairs in there. And then Vx is 2 of your square root of 795, so you write down 2 square root 795. And then for our angle, what we did was we went through and we remembered that all of our angles have been bisected. So WXZ is 34 degrees because the one right next to it is also 34. All of the angles in the middle are right angles, so that gives us 90 degrees for the second one. And then if you look in green, I found 56 for the first one because I highlighted the green triangle there and I added all of its parts to be 180. All right, that's all for rhombi.